Over here, I'll be going through with you a summary to differentiate the factors that affect whether it is a SN1 reaction or SN2 reaction, and what are some of the properties of these mechanisms. Now, first up, the type of alkyl halide or substrate will determine whether it undergoes an SN1 or SN2 reaction. So in this case, I'll be using an alkyl halide as example. For SN1 reaction, because we know that in this pathway, we need to form the carbocation. Alright, so it's about the stability of the carbocation, which means that if we have tertiary, that'll be appreciated. Tertiary RX alkyl halide. Alright. If it's primary, contradictory to here, it'll be SN2, the opposite end. Because SN2, it is a bimolecular reaction, so SN2, you have more steric factor. So that means, right, surrounding the carbon with the leaving group, if there's not much blockage of electron cloud, that's more favored. So that's why primary alkyl halide is favored. You might ask, what about a secondary alkyl halide? So secondary alkyl halide could undergo both. So you need to look at more other factors as the list goes that could influence it to become SN1 or SN2. As for the kinetics, we know that here the number also refers to the order of reaction. So in this case, it is a first order Star Wars. And SN2, the 2 means a second order. In terms of stereochemistry, for SN1, because first we form a trigonoplanar carboxyl ion, so the incoming nucleophile could attack from both the top or the bottom, or we can call it a suprafacial or the anterofacial attack. So in this case, SN1, you have a partial, what we call partial racemization. Alright? But for SN2, the incoming nucleophile has to come from the back of the leaving group. So this must be an inversion of stereochemistry. This term here, partial racemization, just means you could have inversion or you could have retention. Inversion means it's changed. Retention means it's retained, no changed. So SN2, you have to change it. For SN1, you have both options. It could be a mix. Next factor, the nucleophile. Now, in SN1 reaction, remember the first step. The first step just involves the self-dissociation of the leaving group. The nucleophile will come in only in the second step where you have already formed this carboxyl ion. So, it doesn't matter if the nucleophile is strong for SN1 reaction because no matter the strength of nucleophile is, it's still got to wait until I see the C+ carboxyl ion and that will go in and join. So here, it does not matter. Does not matter the strength of it. But for SN2, the only step involves the incoming nucleophile punching out the leaving group. So you need this to be strong. If not very strong, you see, because it's a concerted effort, right, together. So next factor will be the solvent. Now the solvent for SN1 reaction is a polar protic. Okay, polar protic solvents here, you can stabilize the formation of this carboxyl ion. Now, for SN2, we want it to be polar aprotic, so that it does not form a cage around the nucleophile and allow the free nucleophile to just go in and react with the alkyl halide. For the leaving group, we would like both cases to have good leaving group, but in particular, which is even more important, SN1. So it must be very good leaving group. And we have to say that it is a very weak nucleophile / base. Alright? Why? Remember, in SN1, the first step involved the self-breaking of the leaving group and the carbon bond. So just imagine, if they are fantastic nucleophile as a leaving group, so they break first and go up, but they are also good bases of nucleophile, that means they can join back again. So this reaction becomes reversible and you can't get a good yield and drive to the end product. But for SN2, the leaving group should be, again, good. But the thing is, the factor whether it is a weak or strong nucleophile is not worth so much in SN2 because, remember SN2, the incoming nucleophile is going to come in and push out the leaving group. So there is already a force, a momentum and help to kick out the leaving group. So the leaving group should be good leaving group, but it is just a matter of fact that the incoming nucleophile must be stronger than the nucleophilicity of the leaving group. So here you see a summary of the difference in the factors between an SN1, SN2 reaction.